Okay, so we are told that the discrete random variable x has a commutative distribution function given by this function here. So before x is equal to 0, the commutative probability is 0. Between 0 and 1, the commutative probability is defined by this function here. And then for x greater than 1, the commutative probability is 1. So, first part is telling us that k is a constant and that we want to show that k is equal to half. So just remember, we have to actually solve this. What I want to do is I want to use the probability that if I put the maximum value of this function into the function, that it will be equal to 1 because it will have accumulated the total probability. So what we're saying is f of 1 equals 1. We're going to use that property to set up an equation and solve the problem. So what we get is k times 4 lots of 1 squared minus 2 lots of 1 to the power of 4, and that is equal to 1. When I evaluate this line, what happens is we get 4 minus 2, which is 2 times the k, so we get 2k equal to 1, and that of course leads to the fact that k equals a half as required. Okay, so how do I get marks on this question? Well, the first mark is given for, preferably you should state this, but as long as you've stated that as a minimum, you can get your first mark here for stating that that's the equation you're setting up. And then the second mark is given for this whole line here. You need to show that this evaluates to 2k equals 1, and then that leads to the k equals a half as required. So we're really doing this whole line here in order to show k equals a half. Okay, so let's have a look at part B. Part B says show the median value m satisfies the equation 2m to the power of 4 minus 4m squared. So what we're going to do in this situation is we're now going to use the property that if I actually put the median into my cumulative distribution problem, the median is midway, so halfway, so that means I will accumulate half the probability, or 0.5. So again, it's very similar to the first step. We can set up this equation, except this time the unknown is the actual x value, and we're going to replace that with an m so that it sets up this equation which we'll go on to solve. So replacing the k with the constant a half that's you've either just found or you're using because you couldn't solve the first part, we're going to do half times 2m squared minus 2 lots of m to the power of 4 equal to a half. Actually, if I write it like this, it'll make a little bit more sense in the next step that I'm going to do. Now, I don't really like these fractions. I want to get closer to this equation here. So what I'm going to do is if I times this whole equation by 2, then these halves will become 1s, and so what I get left with is 2m squared minus 2m to the power of 4 equals 1. So now just one step away from getting this equation, if I subtract 2m to the power of 4 from both sides, add 2m to the power of 4 to both sides, and I subtract 2m squared from both sides, what we're going to get left with is this exact equation here. Okay, so strictly speaking we'd have 0 on the left hand side and the equation on the right hand side, but as long as the equation stays the same, I can then rewrite this as 2m to the power of 4, 2m squared, 1 second, so it should be 4m squared, so apologies, let's just change that to a 4. This one here of course should be a 4, so just a silly mistake, plus 1 equal to 0. Okay, so how do I get marks on this question? Well, first of all, you can have a mark if you stated just simply f of m equals 0.5. You can then have a mark if you've written out this line here, and that's actually just substituting both the k and the m into that function, the original function that we have defined. Okay, then finally your mark is given for showing once you expand it out, So for these two lines here to show that it expands out to give us this, and it rearranged to give you the final result. You can't simply just step from this line where you've substituted it in to this equation here. You need to show at least one step, intermediate step in that process to really show that the median n satisfies that equation. Okay, so even if you couldn't answer that part of the question, you can still go on and try and solve the next part of the question. The whole point of them giving this equation to you is if you don't know how to set up this equation, if you don't know how to work through it, you don't know that property, is that you can still find the value of m to 3 significant figures. This is essentially a core maths task, and you'll find a lot of the continuous random variables questions are core maths. So looking at B part 2, we're looking to solve 2m to the power 4 minus 4m squared plus 1. Now hopefully you will have noticed that this is actually 2m squared squared minus 4 lots of m squared plus 1. Now why have I done this? Well, it's a subtle difference. Actually this type of equation is called a quartic because it has the highest power of 4, but it's actually because of the way it's set up. It's actually a quadratic in m squared. Some people like to replace the m squared perhaps with a y or not an x in this situation because it's already in this function, but you could replace it with a y or an a or something and then solve that quadratic. So you'd have to say, for example, 2a squared minus 4a plus 1. The other way to do it is just literally, as I've done, write it in brackets like this just to highlight the fact that this is a quadratic. So it's 2 times something to the power of 2 minus something to the power of 1 plus your constant. Okay. Now unfortunately this doesn't factorize, so it means you're going to use the quadratic equation. Remember, when you use the quadratic equation, show the substitution stage fully, show you know how to use the quadratic equation. So don't do the minus 4 in your head straight away. Show that it's minus 4. So plus minus, we're now going to do the square root of minus 4 squared minus 4 times a, which is 2, times c, which is 1. This is all over now. This is all going to be over 2 lots of a, which is 2 lots of 2. So show that substitution stage. That's completely fine. Okay. Then from that point you can just calculate this on your calculator. There's no need to show anything more. This isn't a Core 1 paper where you've not got a calculator. Just put this into your calculator as you see it and calculate the values. So when you put it in, if you do the plus the square root solution, you should get the first solution will be 1.707 to 3 decimal places. If you then do minus the subtracting the square root, you're going to get a solution of 0.292. Okay. Now it's important to remember at this point we are simply looking at m squared here. We haven't actually found m. Now, obviously, to find m, we're going to do the square root of both of these solutions, but you can save yourself a little bit of time because, obviously, think about it at this point, we're not going to have 2 solutions for m. So we need to pick one solution for m only. How do I do that? Well, this thing here, the bounds which are defined for the equation, specify what are valid values for x. Now, this is outside of the range, so we know the probability would be 1 here. Okay, the square root of this has to be greater than 1, so x will be greater than 1, so it can't be this value here. So I know that in that case m will be the square root of 0.292. And you need to explain this step. You can't just put it in. You should really be stating why it is. So we know that m is the square root of 0.292 since x has to lie between 0 and 1. So this gives us a solution that m equals 0.54, and just state that you have rounded this to 2 decimal places as that is your final answer. Okay, so where can I get marks on this question? So initially your first mark is going to be given for actually setting up the correct quadratic equation. So if you've shown a substitution stage correctly, m squared equal to this whole thing, you can have 1 mark. Next, you can have 1 mark if you have stated that m squared can be equal to both 1.07 and 0.292. Next, you can have 1 mark if you have written a line that m is the square root of 0.292 as 0 is less than, because of this bound here. And then finally, your final mark is actually for the answer m equals 0.54. Now if you've got a slightly different rearrangement of this, say you've just done the m squared and then you've finished off by saying m equals 0.54 since it lies in the range, or some variation that makes it clear that this is the only solution because of this range, you can get both marks for that. Okay, so nearly there on the question now. Let's have a look at part C. Part C asks us to find the expression for little f of x valid for 0 less than or equal to less than x less than 1, where f denotes the probability density function of x. Now we know to go from the probability density function to the cumulative distribution function, we integrate. Therefore, to do the reverse process, to go from the cumulative distribution function to the probability density function, we're going to differentiate. So essentially, I want to differentiate the function, d by dx. I'm going to differentiate. Let's just simplify this function straight away. So I'm going to do the half times this. I'm going to differentiate 2x squared minus x to the power of 4. Okay, so this is going to give me 4x minus 4x cubed. Okay, so take the power down. 2 times 2 is 4 times x, decrease the power by 1, so x to the power 1. 4 times 1 is 4, decrease the power gives us the 3. So if I differentiate my cumulative distribution function, I get that it is that little f of x is equal to 4x minus 4x cubed. And really we should just find this over the ranges, so 0 less than or equal to x less than or equal to 1, and then 0 otherwise. Now, you may wonder, why do we why do we want the probability density function from f of x? Because really the cumulative distribution function is more powerful than the probability density function, or so it seems. However, in part 2 it says evaluate the expectation of the square root of x. Well, you can only work out the expectation of x actually from the probability density function, so it does serve a purpose. Okay, so let's just give ourselves a little bit of space to write in. We are now going to do the expectation of the square root of x. So let's start off. What we're going to be doing is we're going to integrate between 0 and 1. Remember, it's the function of x, so square root of x, multiplied by our probability density function, which is 4x minus 4x cubed. And we integrate this with respect to x. Now, we can help ourselves out a little bit here. We've got a consistent common factor here of 4, so I'm going to take that outside the integral. It's not strictly necessary, but it can make life easier for us. So now I'm just going to focus on the functions inside. X, or the square root of x should I say, is of course x to the power of half. So I'm going to do x to the power of half times x to the power of 1. When I add the indices, 1 plus a half is 1.5, or 3 over 2. We're then going to take away x to the power of half times x cubed. So we're going to add the indices again. X cubed written in terms of a fraction is 6 over 2. So just add in that extra half. And remember, if you're not very good with fractions, then you can use your calculator. Okay, so just double check. 3 plus a half is 7 over 2. Remember, we need to write it as a top-heavy fraction. Okay, so now, having expanded that, actually we've done quite a lot of the hard work because we now just have to integrate. So, as I said previously, don't forget the constant. We're going to do that. When we integrate x to the power 3 over 2, when I increase the power by 1, that means I'm going to add 2 to the numerator. So I get 5 over 2. And then I'm going to divide by 5 over 2, which means I flip the fraction and multiply by it. So I get 2x to the power of 5 minus 2. Take away. Integrate x to the power of 7 over 2. We're going to increase the numerator by 2 again, so I get 9 over 2. Again, when I divide by this fraction 9 over 2, I'm going to flip the fraction and multiply it by instead, so I get 2 over 9. Okay. Now, if you're not confident working with fractions, yes, you can use your calculator in a lot of situations, but algebraically, you can't necessarily use it that much. So it is really useful to make sure you're confident with your fractions, because it makes things like this so much easier. Saves you writing the 5 over 2 underneath and then flipping it upside down. It just can save you some time. Okay, so now let's evaluate this. So equals 4. We're going to substitute x equals 1 in, so we get 2 lots of 1 to the power of 5 over 2 over 5 minus 2 lots of 1 to the power of 9 over 2 all over 9. Take away. Remember, good practice, put the 0 in, and so we're going to get 2 lots of 0 to the power of 5 over 2 over 5 minus 2 lots of 0, 9 over 2 over 9. Okay, and square bracket that out. Now, when I use my calculator to evaluate this bracket, okay, what will happen is we'll get a result. This equals 0, so ultimately all I have to do really is this sum of my calculator. This bit here is just for good practice. Okay, it's going to help you later on down the lines. What you're going to get is, if you're using your TrueView calculator properly, you can get the fraction 4 times 8 over 45, which of course is equal to 32 over 45. So just at the end, state that what you've found, that the expectation of the square root of x equals, preferably write it as a fraction if you can, if you've got that on your display. Otherwise, you can write it as a recurring decimal, 0.7171771. Okay. Now, how do I get the marks on this question? Well, you can have 1 mark, first of all, for this part here, where we say we're going to differentiate our cumulative distribution function. You can then have 1 mark when you've stated the probability density function in full. Next, you can then have a mark for this stage here, where we have written out that it's the square root of x times our probability density function. Then have a mark for the correct integration of that function, and finally you can have a mark for the correct evaluation of that function. I hope that all made sense for you.